Hi everyone, my name is Manesh Deb. I'm a solutions architect, analytics specialist at AWS. First of all, I would like to thank you all for joining us today on this webinar where we'll learn how our developer community is building modern applications combining modular, serverless, event-driven architectures using Amazon Redshift Data API. Redshift Data API simplifies access to Amazon Redshift Data Warehouse by removing the need to manage database connections and credentials. Instead, you can run SQL statements using the AWS SDK, which supports different languages like C++, Go, Java, Python, and so on. Using that, you solve different use cases in a super simple fashion, which we'll be learning in today's session. We have recently published a GitHub page getting started with Amazon Redshift Data API on AWS Samples repository. This GitHub project will cover all the code examples that I'll demo today, along with some other cool stuff and use cases. Here is the agenda for today. First, we'll learn what is Amazon Redshift and the Lakehouse architecture with Redshift. Then, we'll learn what is Amazon Redshift Data API and its key features. Then, we'll cover some common use cases with Data API along with short demos on them. Then, we'll learn how to get started with Redshift Data API, covering our GitHub page and blog posts. We'll end the session with a live Q&A. If you have questions during the presentation, please feel free to post them on the chat, and our team would be actively monitoring and responding them. Let's start with Redshift. Amazon Redshift is a fast, fully managed, widely popular cloud data warehouse that allows you to process exabytes of data using standard SQL. It allows customers to analyze all their data at any scale and leads the market in terms of price performance. Customers use Redshift as an integral part of their Lakehouse architecture, connecting their Amazon S3-based data lake with Amazon Redshift Data Warehouse, along with other purpose-built services to build their end-to-end solution. Here is the Lakehouse architecture, which allows customers to build a modern data architecture that enables them to easily access data, not just with the data lake, but different purpose-built data services for their relational, non-relational databases, data warehouse, machine learning, and big data processing services, leveraging the power of native integration among all these services. Here is the Lakehouse architecture with Amazon Redshift, where you can use Redshift as your primary data store and use it seamlessly with other AWS services, leveraging the benefit of AWS native integration. This drastically reduces the time and effort by avoiding the need to build additional complex pipelines. Redshift has a feature called Spectrum, which allows you to query data on Amazon S3 without moving or transforming data. With Redshift Spectrum, you can run SQL queries on your files in S3 that may be in different file formats like CSV, JSON, Parquet, Avro, ORC, and so on. With Redshift Federated Query, you can run live queries in your operational databases like Aurora Postgres or RDS Postgres, or combine data from your relational database and Redshift and your S3 data lake. With Redshift ML, you can use standard SQL to create and make predictions with machine learning models seamlessly from within Redshift. Similarly, with Redshift Data API, which will be our focus for today's session, we can easily create modern serverless applications using AWS Lambda and also build applications using other AWS services like Amazon EC2, ECS, EventBridge, Cloud9, and so on. Here is a high-level view of Amazon Redshift Data API, which simplifies access to Redshift from all these different AWS services like AWS Lambda, EC2, ECS, SageMaker, EventBridge, AppSync, Cloud9, and even on-prem applications using the AWS SDK. Here are some key features which makes customers love Data API. We launched Data API last year in September, and more than 5,000 of our customers are already using it for variety of their use cases. First of all, Data API doesn't need a persistent connection with Redshift. Instead, it provides a secure HTTP endpoint that you can use to run your SQL statements. Therefore, there is no need to manage or set up VPC, security group, and related infrastructure to access Redshift with Data API. As it integrates with AWS SDK or Software Development Kit, you don't need to set up additional drivers like ODBC or JDBC drivers. This one is my personal favorite: no password management. With Data API, there are two options to provide credentials. The first one is using AWS IAM temporary credentials, where you only need to provide the username and get cluster credentials IAM permission with no passwords. Data API automatically handles retrieving your credentials using AWS IAM temporary credentials mechanism. The second one is AWS Secrets Manager, where you store your username and passwords in an AWS Secrets Manager secret and allow Data API to access those credentials from that secret in a secure fashion. Another important feature is its asynchronous nature, which is key in developing microservices based architecture. For example, you may run a heavy multi-hour process in the database, say a stored procedure. As the stored procedure would be running inside the database, you don't need to maintain a long-running connection from your application server for the entire duration to keep track of the stored procedure. Instead, you simply initiate the statement using Redshift Data API. After that, you can either poll Data API on periodic intervals to see if the statement got finished, or you can use event notifications, which are automatically sent by Data API to Amazon EventBridge or CloudWatch events to take further actions if necessary. This allows you to design event-driven applications with Redshift, which are getting very popular among our customers. Another key benefit with Data API is cost. There is no extra charge for using Redshift Data API, meaning you can use all these benefits at no additional cost. Last one on my list is its support for various languages. As Data API integrates with AWS SDK, you can build your application code in any language supported by the AWS SDK, like C++, Go, Java, Python, and so on. This is how you interact with Data API using all these languages or the AWS command line interface or CLI. Say you want to select some data from Redshift table. With AWS CLI, you can run this command AWS Redshift data execute statement and pass these parameters, and then Data API would run this statement for you in AWS CLI. Using similar parameters, you can run this query in other languages too, like Python and Node.js as shown in this example. Here are some customer success stories with Data API. Our advanced partner, Data Coral, was able to use Data API to offer their customers an event-driven serverless platform along with cost and scale benefits. Zynga, a game development company running social video games, was able to leverage Data API to enable programmatic Redshift access to their clients with AWS IAM authentication in various languages like PHP, Python, and Go. Now, let's move to some common use cases which highlights designing modern applications combining modular, serverless, event-driven architecture. The first one is how to simplify data access from your applications, which may be an application hosted on Amazon EC2 or ECS, or a serverless application built with AWS Lambda. The second one is more popular with our data science community on how to access Redshift data from their Jupyter notebooks, especially Amazon SageMaker notebooks. Third one, popular with our developer community, is to access Redshift using REST methods like GET or POST APIs. The fourth one is getting popular with our data engineering community, which is to design an event-driven extract, load, transform, or ELT pipeline where external or internal events trigger your data pipeline, ensuring immediate delivery of data to the end users. The fifth one is designing event-driven web applications, especially if you'd like to avoid long-running database queries, creating bottleneck for your application server. The last one is designing a serverless data processing workflow where you design an end-to-end application orchestration using serverless AWS components like AWS Lambda, EventBridge, Glue, step functions, and so on. Again, these are just some common examples, but customers are using Data API for many different use cases, which may be unique to them. Now, let's move to the demo part, where I'll be showing you a working example for these use cases. The first one is how to simplify data access from your applications. Say your application is hosted on an Amazon EC2 server, which I'll be logging in shortly. In this instance, I have already added a generic shell script, redshift data.sh, to access Redshift using Data API. Using this, I'll create a table called Redshift table, and then I'll insert one record in this table, and then I'll select data from this table using Redshift Data API. Let me switch to my EC2 instance and run the statements. First, I'll create the table. I can see it gave a message statement completed. Then I'll insert one record saying I love Data API. After that, I'll select data from this table. I'm running the select star from this table, and at the very end, I can see that it returned the output, which is right now YAML formatted, but you can format it, say, text or JSON or whatever formats the AWS CLI supports. And here is my data, which is saying string value notifying the timestamp, and also the string value I love Data API. Now, let's see what's inside this script. Let me vim to the script redshift data.sh. And you can see I'm passing these three parameters, out of which first two are static parameters for my Redshift cluster endpoint and the Redshift username. The third one is a command line parameter, which I was passing all my SQL statements. This script uses Amazon Redshift Data API to run execute statement to run the SQL query that I have passed, and after running it, it polls every 1 second to see if the statement got completed using Redshift Data Describe Statement command. And at the end, it shows the end results back in the command line to see what's the output of the SQL statement that I ran using Data API. Let me come out of the script. We just saw how to access Redshift Data API using AWS command line interface. Similarly, we may also use other languages to access Redshift Data API with almost similar concept. Let me show you how to use Data API with Python. I learned the statement Python 3, and then I have a script redshift data.py. I learn this statement and see the results. As you can see, this also returned the data I love Data API in a nice formatted way in a tabular fashion, which is coming directly from Python pandas data frame. Let me show you what's inside this Python script. Similar to the CLI example, here also I'm passing the Redshift cluster endpoint and Redshift username as static parameters, but this time the SQL script I'm inputting from Amazon S3 bucket. So in this Amazon S3 bucket, I have already stored a SQL script, which is similar to what we ran with AWS CLI example earlier. And then we are using Redshift Data API to execute statement that has been passed by this SQL script. And then I'm polling every 1 second to see if the statement got finished using describe statement API. And at the end, I'm fetching the end results using get statement result and outputting it to a pandas data frame. And at the end, you can see this is the output that I saw on the standard output, which is getting outputted from the data frame directly. You can see how easy it is to work with AWS CLI, Python, or any other language with Redshift Data API. Let me move back to the slide deck and move to the second demo. My second demo is accessing Redshift from Jupyter Notebooks. For this, I log in to my AWS account where I have already provisioned a notebook and open this notebook file where I'm showing how to use Redshift ML with Data API. Similar to the Python example I showed earlier, this is connecting to Redshift using the Redshift Data API client, and then it's running the execute statement to run the SQL statements that are being fired. After that, it polls every 1 second to see if the statement got completed or finished, and then it fetches the results using Redshift Data get statement result API call. And at the end, it displays it back to a pandas data frame that the user can use to analyze and visualize. So in this script, first I have this big script creating all the tables and loading data onto it. Then I'm running them using this function I set up earlier, which is run SQL. And after loading all the data, I'm running the script select trip count trip name from trip data, which is directly outputting my dataset into a pandas data frame. Then I'm using some nice visualizations using Python library matplotlib. And then at the end, I'm actually creating a model using Redshift machine learning using a simple select statement. And once this model is created, I'm comparing what is the predicted count by this model and what is the actual count that I had in the database earlier. So you can see how easy it is to access and visualize data using Redshift Data API, which is getting popular among our data scientist community or even the analyst community who are using Redshift ML capabilities and various other ML libraries. Let me move to the next use case, which is designing an event-driven ELT pipeline. Let me start with an example. Say an external vendor sends you data periodically. As soon as the vendor notifies you about the data publish, an event gets generated in Amazon Event Bridge to trigger a Lambda function. This Lambda function then runs your ELT pipeline to load the data from Amazon S3. And once the data is loaded, you can send a notification to the analyst team about availability of fresh data so that they can start working on it. For my demo, I have used Amazon EventBridge scheduled event rule to initiate an event based on a time interval. The target of this rule is a Lambda function, which will call a stored procedure using Redshift data asynchronously, which is run the stored procedure irrespective of how much time it takes, and the Lambda would take just 1 or 2 seconds to complete, though the stored procedure may take 30 or 40 seconds to finish. Once the stored procedure is finished, it will send an automated notification to Amazon Event Bridge, which will have a different rule to trigger a Lambda function to notify my end users. Let me move to the AWS console and show you this example. I'm in my AWS console where I have already set up an Event Bridge rule which runs every 1 minute. This rule has a target Lambda function which runs a stored procedure on that particular interval. So you can see the stored procedure name is run ELT process, which should be running every 1 minute from this Event Bridge rule. If I go to the logs of this particular Lambda function, I can see the logs output where it is running this statement call ELT process, and the Lambda is taking about 1300 milliseconds, which means 1.3 seconds to finish this command. But if I navigate to my Redshift console and go to this queries and loads tab, I can see this stored procedure being running every 1 minute, but it takes about 28 seconds or 30 seconds to complete. What happens behind the scene is first the event bridge rule would trigger a Lambda function, and then Lambda function would just run this statement, handing it over to Redshift Data API, and the Lambda function would get completed. The statement would run in Redshift, which is taking close to 30 seconds now to complete, and then it's actually notifying back to Event Bridge, which is being captured by another Event Bridge rule, which captures all these events from AWS Redshift data. And in this event, I have another Lambda function, which is actually notifying the end users saying the ELT process is completed in Redshift. And this is the end-to-end architecture of how to design an event-driven ELT pipeline leveraging Redshift Data API. Let me move back to my slide deck and move to the last example, which is designing event-driven web applications. This also leverages Redshift Data API along with Amazon API Gateway WebSockets APIs, which are especially useful in designing a decoupled web architecture when dealing with long-running queries or operations like analyzing massive amounts of data in a database. For example, you may be running a web application that has a long running database query taking more than a minute to complete. Instead of designing that web application with long running API calls, you may use Redshift Data API and Amazon API Gateway WebSockets, which would create a lightweight WebSocket connection with the browser and then submit the query to Redshift using Data API. Once the query is finished, Data API would send a notification to EventBridge about its completion, which would then trigger a Lambda function to push the results back to the end user's web browser. Let me open my browser to explain this further. Here, I have an index.html page in my local where it's asking me to input a month and year to analyze New York taxi data for 2015. Let me provide the same. I'll select any random month and then hit done. And I'll also start inspecting this web page to see what's happening behind the scenes. I'll go to console to see the logs and then hit submit. You can see as soon as I hit submit, it's actually opening up a WebSockets connection and also passing the parameter, which is the trip month and year. And this statement will take a couple of seconds to complete. Let's wait for that. Here we go. You can see the web browser is now populated with some dataset, which is actually coming from my Redshift data warehouse. And here is the output that has been pushed by Redshift Data API. What's happening here is first, this particular WebSocket got created, and that WebSocket created a connection and submitted the request with Redshift Data API. Redshift Data API then ran that statement, which took a couple of seconds to complete, and then notified EventBridge. EventBridge then used a Lambda function to push the results back to the end user's web browser. That way, you created this push-based mechanism to post data to the end user instead of maintaining a long-running connection or a long-running API to achieve the same results. That concludes my demos for today. Now, I'll navigate to the GitHub page where you could find all the code base for the examples I used today. Here is the GitHub page, getting started with Amazon Redshift Data API in the AWS samples repository. And in this, we have quick start examples that you can use to get started with Redshift Data API. And you can see we have Go, Java, JavaScript, Python, TypeScript as different language options, which guide you on how to get started with Redshift Data API with all these different languages. And we're also adding other languages as we go by in this repository. We also have another folder, which is use cases, in which we have documented all the different use cases that I covered in today's session. And we're also adding more and more use cases as we see our customers leveraging Data API. And this is a GitHub repository, which you also can contribute by submitting a pull request. So if you have some use cases which you think would benefit the developer community, please feel free to send pull requests, and we'll be adding that as different use case examples or even quick start with different languages. We'll be adding them in this repository, which would benefit the entire community. These are some references you can use to get started with Data API. And also, please help us by contributing in this GitHub page so that we can make it a robust mechanism for all our developers leveraging Redshift Data API. With that, I'd like to move to the Q&A section. Please post on the chat if you have any questions regarding today's session, Data API, or Amazon Redshift in general. Thank you.